Hello, hello.
Hello.
I'm not entirely sure if we should just kick things off, or are we waiting from like the Taikai side to moderate this? But let me send them a ping, and if not, we can kick it off, Rafa. Perfect. We can start. Rafa, I'll let you go.
Okay, good. So hi everyone. Let me just share my screen. Okay, guys. So today the idea is to present you a very new product that we are launching currently that week. The idea is to first of all, at Giza, what we do, we try to simplify the way you are building ZKML products, applications, and protocols. The idea of ZKML is, as I explained yesterday during the presentation of Giza, the idea of ZKML is to have machine learning verifiable in order to verify the integrity of your inference. And that could be interesting for some use cases like in the healthcare, in the finance, etc. But also it's also a way to superpower your smart contract with some smart features thanks to machine learning. So the idea is to verify the inference off chain and prove it on chain. So now that we said that, how we do that, we do that with proving the inference of a machine learning model. But the idea to prove the inference of a machine learning model, we have to take your model and create ZK circuit on top of your model in order to prove it. In our first iteration, we created Orion, which is a library, a framework where you can create machine learning models with a Cairo language. And with the Cairo language, what you can do, you can build ZK models with that. But that was nice, and the Orion is fully open source. We have 30 contributors now, and you can start building with Orion. But if we want to onboard more developers, and also if you want to stay in the same environment that you are building machine learning models, we had to create a Python SDK. Okay, so this is what we are releasing today. It's a Python SDK to build your machine learning models, and also a platform that I'm going to show you in order to monitor and to track your workflow. So what I suggest to you I prepared a notebook with a very simple model that is like the hello world of machine learning with the MNIST. The idea is to use the MNIST data set and to see how we can use the Giza SDK with that. Okay. So first of all, what is MNIST? MNIST is a data set with handwriting digits. And it's a very famous data set that you can use. And the idea of our workshop today is to use that data set in order to predict your model. So first of all, because we will use the Giza tools, you have to log into Giza and create a workspace. So you can do that first by installing the Giza CLI, okay? And then do Giza users create if you didn't create any account. Then you log in, and then you have two ways. Yeah, you can have a token, but you have to, if you are using the token JWT, you will have to relog a few times every 2 hours, I think. So we suggest to use that create API in order to have an API key in our credentials. It will be easier for you during your development. Okay. Then once you created your account, what you have to do is to create a workspace. What is a workspace? Is a UI where you will be able to monitor your workflow. I'm gonna show you in a minute how it looks like. But the idea is to have that UI. So you, again, because you download that Giza CLI, you can have in your, you can tap in your terminal Giza workspace create. It will create a workspace, and in the future, if you forgot the link, you can do a Giza workspace gate in order to get the link. So I'm gonna show you maybe if I do Giza workspaces get, and I have that link. And now if I go to that link, it will open a dashboard where I can see all my actions, my workflow. I'm going to talk about that workflow in a minute, but I can monitor it, and I will dive more into it in a minute. But the idea is, okay, you have in one dashboard all your workflow that you created. Okay. Then now that we logged in and created workspace, we have to, for our MNIST tutorial, we have to define our model. So it will be a very straightforward neural network. Usually the MNIST is 28 by 28 pixels, okay? But here, and for better performance, we will resize that images to 14 by 14. So this is what we do. This is why the input size is 96. And here we are defining our model. As you can see, it's a very simple one. A linear model with a linear layer with a real U and a linear one again. So now what we need to do is to pre-process our data set, and we need to train it. What we will do here with that SDK, we will create tasks. The idea with task is it's in the name, you know, you are creating tasks in order to monitor it with the SDK, the workspace, in your workspace. So what you have to do is to import from the Giza action your task, okay? And the only thing that you have to do is to add the task decorator in your function. But the function is the same, like it's exactly the same that you are writing your Python your Python function. The only thing that you have to add is the task with a name if you want. It's not mandatory, but it's better with a name. And then you just have to run it. Okay, so let's run it. So here in that task, what we do, we prepare the data set. So we download the data set from MNIST, we size it, and we split the data set between train set and test set. Okay, so the data set for the training part and for the testing part. Then we have another task. We will create loaders here. So this is what we do here. And then we have to, we are creating a method, a new task to train our model. Okay, so this is what we do here. And finally, another task that we want to define is when we will test our model in order to see the accuracy. Now that we created that test, we need to action that test. Okay, so the action is the execution of all your tasks. Okay, the idea here is to add this new decorator called action, and with that action decorator that you get from, if you see the imports that you get from the Giza action also, and from that where is it? And from that action, it will just execute the action. So if you see, it will execute all my tasks that I defined previously. So it prepares the data set, it creates loaders, and it's training my model. And I can see that I have an accuracy of 91%. Okay. Now that I run that action, what is good is that during the running, and once it's already run, I can monitor it. So here I see my action, my runs. Okay, so this is the action that I just run, and here I can see the entire flow. Okay, you can also dive into one task. So here you are checking the task. We just have a small issue with the logs, but this should be fixed that week. You can see the logs in your terminal, but not in the platform right now. But this should be fixed very soon. But also you can see a lot of metadata about your task, etc. Okay, so it's a better way to monitor it. Once you have that, you can also deploy your actions. So the idea of deployment is you prepared a deployment in order to run it asynchronously. It could be later or whenever you want. So in order to make a deployment, you have to, once you define your action, you have to do it like that. So you are calling the action class and the entry point. Okay, so each deployment has to have an entry point, and then you are serving that entry point. You cannot run that deployment in a notebook. That is not possible. So what you have to do, what I did here, I recreated the code that I show you in another Python script. And here at the end, you see my code to deploy my model. Once you deploy your action, you will see all your deployments in that section. Okay, so here I can see my deployments and I can run it. So I can create custom runs or a quick run. And if I do a quick run, it will be scheduled and start very soon. And then I can again monitor it, see details about it, etc. Okay. So this is how deployment actions are working. Here, by the way, you are seeing all the actions that you do, and here all the runs that you are executing from the actions. Okay, so now that you have a better idea how the action is working, what we want to do is to run and prove it, okay? Because we are doing ZKML here. So the idea is to have maybe, let me see if I have. Okay. So how it will work. So now when you are using the action SDK, what we want to do, we want to first transpile your model, okay, to ONNX. ONNX is intermediary framework representation for many models. So for example, if you have for many frameworks. So for example, if you have a PyTorch model that you want to translate to TensorFlow model, you can convert to ONNX, and then from ONNX to TensorFlow. And what we created with Orion is another ONNX representation, but in Cairo. So with our transpiler, you are taking your ONNX, your model, you are converting that in ONNX, and that ONNX representation is transpiled to Cairo in order to make it verifiable. Okay, so and then once it will be converted to Cairo, you will be able to run that that Cairo program in order to prove it. So this is what we do here. You are using the Action SDK and the Giza platform to transpile your model, to run to deploy, we will see that in a minute, to deploy your transpiled model in the Giza platform. And then from the Action SDK, once your model is deployed and converted to Cairo, from the Action SDK, you can predict it. It will use the Cairo version and prove it, and then you will be able to verify it. We will see that full stack in a minute, okay? So this is what we want to do. But first, as I said, we need to convert my model to ONNX. So I have my model that I created in PyTorch previously, and now I want to convert it to ONNX in order to then transpile it to Cairo. So to convert that in ONNX, I will create again another task to convert that. And then I'm gonna just re-execute another action that will convert to ONNX. So this is what we do here. In that execution, I just retrained, etc. So we are retraining my model, but you could use the model that we just trained previously. And then the model has been converted to ONNX. Okay, now that we have that model converted, we will use again the Giza CLI to transpile my model from ONNX to Cairo. Okay, so in order to transpile the CLI, I will use that that command line to and give the path of my ONNX model in order to convert it to Cairo file. Okay, so I'm gonna just show you how it looks. Copy relative path. So here we are calling the CLI to transpile the model. The model is the transpilation is in process. And I should have where I put put it here. Okay. So if I dive into that generated directory, I have two directories. I have the inference that you can see here, which is a Cairo file. Okay, that the Cairo representation of my model. Okay, so this is the Cairo representation of the model. And I have initializers. Initializers are bias and weights in our case, but it could be other tensors that are initialized in our inference flow. Okay, so here is one of the bias of the layer one. Okay, you have the weight of the layer one, etc. Okay, and all that initializers are imported in that model. Then once I created that Cairo, you don't have to care about that Cairo part if you don't know Cairo, because what we wanted to do with that SDK is to abstract Cairo as much as possible. The only thing that you have to do is to compile that Cairo program into Sierra. So what you have to understand is that when you transpiled your model in our Giza platform, it created a model and a version, okay, of that model. But now what we want, we want that you compile your model to Sierra. Sierra is an intermediary representation of Cairo, okay, between the Cairo and the chasm and the Cairo assemblies, the chasm. So we want that you compile that that project to Sierra, and then you can create a deployment to the Giza platform. Why we didn't create that in the background? It's because maybe you want to modify that file with some changes, or maybe also during the transpilation something was not done correct, was not transpiled correctly, so maybe you want to dive more in your Cairo file to fix it, and then you can just give us the Sierra file. So in order to compile your program, your Cairo program to Sierra, it's very easy. You just have to go to your inference project. So let's do verifiable inference, and then you just have to do scarb build, okay, and that's it. By doing that, it will create a target dev directory here, and here you have the Sierra file. Okay, once you have that Sierra, you will want to create a deployment. Okay, so when you created that, when you transpiled the model, sorry, it returned a model ID and a version ID, and based on that you can create your deployment. I already created the deployment, so I'm gonna not do that, but you can see your deployment by doing Giza deployments list, and you are giving the model ID. I think mine is 49, and version ID, I think mine is 3. And by doing that, so once you deployed it, you can see it when you list your deployments, and that created a URI that you can use in order to run your inference. But in the Giza CLI, we abstract it, so you don't have to use the API. But if you want to use the API, the link is that. So you are using the URI plus Cairo 1, and if you are doing a request to that URL like that, it will this is a request for the model. It will run the inference. Okay, so I'm just checking if, yeah, something that I didn't mention, if an operator that is not supported in Orion or in the transpiler, the Sierra can fail. So if that is not supported, please let us know so we can help you and see if it's just something that we can fix quickly, or if you have more to dive into your Cairo code in order to fix it, and then you can just send us that, you can just send to the Giza platform the Sierra file, okay? Now let's run it. There is two ways to run your program from the SDK. You can run it from a verifiable mode or a non-verifiable mode. When you are running your program with verifiable equal to false, it will just run the ONNX file. Okay, so this is what we do here. So first, when in the context of that tutorial, we need to pre-process our image. I just give for the prediction the 0, okay, the digit 0 as an image. So we just have to pre-process that that image, resize it, and make a prediction, okay? And as you can see here, the verifiable is in false. This is not needed, by the way. And again, this is a task, an action, an execution. So I will run it again, and it predicted the right value. I can see it in my action runs. Okay, I see that it started with pre-process and then the prediction. Okay, I added that huge UUID. I should short it, by the way. It's just that there is a warning when when you are using non-unique names, but we can fix it later for better user experience. It just now, if you want to avoid that warning, you can just give something to have your name unique. Okay. So you see it predicted well the prediction, and now another thing that you can do is to make it verifiable. So for the verifiable part, we are just working on it currently, so I cannot show you exactly how it's working, but because there's just some issue with the deserialization part, we just fix it now. But I can show you from the API call. So if you are doing the API call and you are giving the argument, of course that argument is really ugly, but with the SDK, everything is serialized from the SDK. So what we do here in the SDK, we are doing the prediction, we are giving the image, the image is the result of that pre-processing image, which is an NumPy array, okay? The NumPy array feed in that predict, okay? And you have to give the verifiable to true, and also you have to let us know the output data type that you expect, okay? I'm not sure that it will work. I tried 1 minute before the workshop and it failed, but no, it worked. Okay, it worked. So so it worked on that, and now when you are running the program with verifiable mode, okay, it in parallel it will starting a job in our platform to proving your inference. Okay, so to proving your inference, and then you can easily download that proof and verify it. This is the only thing that are missing in the CLI, so we will update that tutorial very soon, today or tomorrow. We can also already use it from the API, so I will share with you that missing part, but it should be ready very, very soon. But the idea is, yes, once you created your model, you convert it to ONNX, you deploy your model in the Giza platform, and then you run it in unverifiable mode if you want just to run the ONNX non-verifiable model, or you can give the verifiable to true if you want to run the Cairo version of the model. And when you run the Cairo version of the model, it returns, it's running on the Cairo VM, and the Cairo VM will generate the trace and the memory files that we are using in our platform to prove your model. Okay, and then you can just download that proof and verify it whenever you want. That missing part for the proving part, I'm gonna just share that very, very soon. Voila. Do you have any questions? Where is Zoom? Yeah. Yeah, I will share the IPYNB with you. Maybe I can share it with you now. It's in Giza action. Yeah. Okay, this is the link. Today or tomorrow, I'm gonna merge it in main branch. So maybe the link will fail, but you will just find it here. You just have to go to the Action SDK, or the Action SDK is in private. We will do it. We will make it public today. So we will share with you on the Discord all the resources. Okay. For the Giza Actions track, are you looking for submission to build? Both, like first we want like people are using the SDK and give us a feedback, of course, but it's also a good way to create real applications. So let's see what you are building, but if you have a feature in mind, it could be interesting to hear your thoughts also. I don't know, Fran, if I missed something or if there is something that you want to dive on.
All good, Raf.
Great. Perfect. Then we can close it here. Looking forward to hacking with everyone. Please feel free to let us know on Discord if you have any questions. Thank you, Rafa, for hosting it.
No problem.
Have a great week.
See you.